Inferential statistic that we have to calculate is the Mann Whitney U test, and if you look at the formula there, it looks absolutely terrifying, and I wouldn't have a clue how to interpret that formula. However, it is an incredibly easy test to do, as hopefully we'll see now. The great thing about the Mann Whitney test is it doesn't make any assumptions about the data, so your data doesn't have to be normally distributed. You don't have to have the same amounts of data point in each set that you're looking at. So if you've got the opinions of 4 males and 20 females, that really doesn't matter either. So you can use it on absolutely any type of data as long as it's ordinal data. So it's perfect for things like opinion polls. Do the opinions of one group of people differ from the opinions of another group of people? So we won't even look at the formula, that's way too scary, but we'll come back just to look at the table that we have down the bottom here in a minute. So the great thing with the Mann Whitney is that you don't think of it as maths, just think of it as a competition. And in this competition you have 2 teams where each piece of data is one of your team members. So if we have a look at this data here, say we ask the opinions of males and females on a score of 1 to 10, how much do you like chocolate? Okay, so the first thing to do is to have a look at it and think about which will be the winning team, if you like, which team will have the highest average. And if we look here, I'm guessing probably that the females are going to be slightly lower than the males, but we'll do it for each anyway. So what you need to do is to on this, the competition is just to be the highest number. So, and each number is going to play it. So 7 will say, am I higher than 4? This 7 here, am I higher than 4? This 7 will say, am I higher than 8? Am I higher than 4? Am I higher than 7? So obviously you can win, you can lose, or you can draw. Okay, so pick the team we think we lose. I'm guessing the female, but I'll do it for both just to do the calculation for each. And we count how many times it's going to beat. So if 4 played against 7, it would lose, that would lose, that would lose, that would be a draw, so it's half a point for that. It would win that one, so 1.5, 2.5. So this 4 scores 2.5. I'll just make this a different colour so it's nice and obvious. This 8 will win 1, win 2, 2.5, 3.5, 4.5, 5.5, 6.5. So that did very well. The 4 will only win two games and draw 1, so that's 2.5. And the 7 will draw that one, so half, 1.5, 2.5, 3.5, 4.5, 5.5. So we add all of these together, and that generates the statistic here of 17. And what we need to look at is in the table, we add up all the wins, and we look at the team members. So in this team I've got 1, 2, 3, 4, and this team I've got 1, 2, 3, 4, 5, 6, 7. So if we go back to the spreadsheet, then we've got 4 here in set 2, we've got 7 here, and our critical number is 3. Okay, if we look at it the other way around, 4 and 7, of course we've got 3 there as well. So going back to the test statistic, critical value is that, but what you have to be for it to be significant in the Mann Whitney is for it to be less than the critical value. So we'll just do the same on this side, just to prove that it does work. So we've got 1 win, 2 wins, 2.5. I'll make that red again. We've got 1, 2 wins for that one. 8, we've got 3.5. 4, we've got 2 draws, so that's 1. 3, we've got 0. 2, we've got 0. 6, we've got 1, 2. Add all of those up. we get the value of 11. What we're actually interested in here, is it less than the critical value? So the critical value again was 7 by 4. 7 by 4 had to be less than 3, so we don't have a significant difference in those. If we look at some other data I've just collected here, this is for, on a scale of 1 to 10, how do you like wearing a skirt? And what we can see here this time, if we, fairly obvious that the males are going to lose, so we'll do it again. 1 plays 8 loses, 1 plays 7 loses to everything, so it's 0, 0, 0, 0, 0. The 2 here, we have 1 draw, so that's 0.5. Oops, 0.5. Okay, so that's the value that we've calculated. Now we look it up on the table, and we've got a 6 by 6 this time, so 6 and 6, and the critical value is 5. We are much less than that, so we do have a significant difference between males and females in how much they like wearing skirts. So, very scary to look at. Hopefully you can see it is very simple to calculate, and importantly, this is the method to do it. So we look it up. If it's less than the critical value, the difference it is not significant. So there you go. There's the Mann Whitney U test.